at AP Review. This is 2018 ABBC Free Response 3. You're given a graph in this problem, and it looks a lot better on the paper, so please use the paper as I go over this. The graph of the continuous function g, the derivative of the function f, is shown above. So again, this graph g is actually f prime. That matters, right? They told us that. Okay. The function g is a piecewise linear function from -5 until 3, right? So line, 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 and then turns into this parabola from 3 to 6. Cool. If f of 1 equals 3, what is the value of f of -5? Cool. So this is a fun twist on the first fundamental theorem of calculus, right? So if we're looking at f of 1 and f of -5, if we were to integrate f prime of x, which we'll talk about in a sec, right, from -5 to 1, we would get f of 1, which is a value that we were just given, right, minus f of -5, which is a value that we want, right? So if we want to solve for f of -5, we could add f of -5 over and subtract this integral. So essentially my f of -5, which is the quantity that I want, is f of 1, which is a known quantity, minus an integral that I can calculate using area of these nice convenient geometric shapes, because notice that this went from -5, which is here, right, -5, until 1. So it seems to me that I have a trapezoid that is going to be a negative, and I have a triangle that is going to be a positive. So I get that this f of 1, which is a 3, right? So this is a 3 minus, and then in parentheses, it's going to be this negative trapezoid, right? It's going to net negative because it's below the axis, plus this flat spot that has no area at all, so it's a 0, plus this positive triangle, right? So if I go ahead and find values for those, right? This trapezoid has a height of 3. That's technically -3 if that's the easier way to think about it, right? The base is 1, 2, 3, 4. Again, easier to see if you're looking at the real graph, and this base is a 3. So the area of a trapezoid is 1/2 the height times the sum of the bases. So this is a -21 halves, right? And then this has a base of 1 and a height of 2, and the area of a triangle is 1/2 base times height, so that'll be a +1, right? So what ends up happening when I clean this up is I end up getting that this is, and if you want to make everybody over halves, you could. I mean, at this point, it's clear that you're going to need halves. So this is 6 halves, right, plus 21 halves minus 2 halves, right? So I end up getting 6 halves plus 19 halves, which is 25 halves, right, or 12.5 if you like it better. Cool. Anytime you're handed a graph that has these nice convenient shapes, whether it's triangles or trapezoids or semicircles or quarter circles, you're going to be asked to integrate and use your knowledge of geometry to find area. Cool. Part B. Evaluate the integral from 1 to 6 of g of x dx. So the part that's tricky is that 1 to 6 is going to involve two pieces. It's going to involve the piece that is this rectangle. That piece is pretty easy, and it's going to involve a piece that we actually have to integrate using our knowledge of how to integrate stuff, right? So we can't just use area. So we go to do B, right? When I do the integral from 1 to 6 of g of x dx, that's going to be the integral from 1 to 3 of g of x dx, which is just an actual box, like it's this box, right? It's 2 by 2. That's a 4 because it's this 2 by 2 box, right? It looks like this. Plus the integral from 3 to 6 of 2 times x minus 4 quantity squared with respect to x. Now you can FOIL this out if you want. I think that's a mistake. I think it's way easier to use u substitution here, especially because if you do, your u is x minus 4 and your du is just dx. So it really, you can do this u substitution essentially in your head. This is like it's a 2u squared. So when you up the power by 1, it would become a 2u cubed divided by 3. So this is going to end up being a 2u cubed divided by 3, evaluated from 3 to 6, right? So I end up getting that this is a 4 plus, when I plug 6 in, right, I'm going to end up getting that this is a 2 to the third, so I'm going to get 16 thirds, minus, when I plug 3 in, this is going to be a -1, right? -1 to the third is still a -1, so that's a -2, so minus a -2 thirds, right? So I'm pretty sure that I get 4 plus 18 thirds, right, which should be a 10, because that's a 4 plus 6. Cool. All right, part C. For the open interval from -5 to 6, on what open intervals, if any, is the graph of f both increasing and concave up? Give a reason for your answer. Okay, so this is going to involve sort of that flow chart we've used in other videos. Let's talk about what it means for f to be increasing and concave up, and then we will find the images on my really terrible graph that I have marked up horribly. We'll find the images where that's true. Okay, so in part C, we're asked for two things. We're asked for where f is increasing, right? That's the ask. And we're asked for where f is concave up. Want to double check that I'm right? Yep, increasing and concave up. Okay, so those are two separate asks, right? After we're asked something, we want to go to what is the actual mathematical definition of that. Well, if f is increasing, the definition of that is that f prime is greater than 0, right? So we then translate that to this problem, right? What it would mean for f prime, which is this given graph, right? This graph is f prime. What it would mean for that to be greater than 0 is that the given graph, right? The given graph is above the x-axis. Okay, so that's what we're looking for in this problem. And sometimes you need a couple steps to make that mental leap, but here that's what that is. Now let's talk about what it means for f to be concave up, and we'll come back to this half of the question in a sec. The definition of f being concave up is that f double prime is greater than 0, right? That's the definition. So we were asked for concave up. That's the question. The definition is that f double prime is greater than 0, but now we need to start to translate it to this problem. Well, the graph we're given is f prime. So that f double prime is the derivative of f prime, meaning the derivative of f prime is greater than 0. Remember, derivative is like slope, so the slope of f prime is greater than 0, right? We're looking for where the slope of f prime is greater than 0, right? Meaning we're looking for where the given graph, right, where the given graph is going uphill. Like, if you're looking for a better way to say it, literally the given graph is increasing. That's what we're looking for, is whereas the picture I'm looking at increasing. So now if we take these two things together and say, hey, we're looking for the interval where both of these are true, I'm looking for where the graph that I'm given is physically above the x-axis. Well, that rules out everything over here, right? This is all not above the x-axis. So right away, I'm now looking only at this window, right? So that rules out anything over here. But then I'm also looking for where the given graph is increasing. And if we look, the given graph is increasing here, right? So the first interval I get is the open interval from 0 to 1, right? And then I'm constant, so I'm not increasing, and I'm decreasing, so it's definitely not increasing. But then here at 4, until the end of the problem, I'm increasing again. So 4 to 6, I'm increasing. And they asked me for the open intervals where both of these things are true, and that's my answer, right? So when you're asked these things, they're asking you to translate words into math and then apply it to the picture you're given. And if you do that in a step-by-step process, if you take what you're asked and translate it to the mathy definition and then translate it to what you can see with your eyeballs, you're going to find that most of these problems are actually pretty accessible. All right, part D. All right, find the x-coordinate of each point of inflection of the graph of f. Give a reason for your answer. Now that's going to tie really nicely into this flowchart we made, because notice we've already talked about how f is related to the graph that we're seeing with our eyes, and how f double prime is related, and we need f double prime for points of inflection. So let's go ahead and do part D. So for part D, right, we want points of inflection for f, right? So that's the ask, right? That's the thing you're asked. So then in your flowchart, you're going to say, okay, that's the thing you asked me for. What is the definition of that? Well, the definition of a point of inflection for f is that f double prime of x equals 0 or does not exist, right? And changes sign, right? So we want it to change sign from positive to negative or negative to positive. So that's the definition. Okay, well then let's loop down here and start talking about what we can see in this problem, right? What can you see with your eyeballs? So you need one more thing to relate this before we can get to the looking with my eyeballs stage. Which, remember, if you want to sound fancy when you talk about using your eyeballs to solve something, say by visual inspection. So by visual inspection, we can usually find things out, but that just means you used your eyeballs. So cool. We know the relationship from part C was that f double prime of x is actually the derivative of f prime, right? Because this graph, right? This graph right here is f prime. So in this problem, what we're saying is the slope of the given graph, right? The slope of f prime so the slope of the given graph equals 0 or does not exist, right? And changes sign. That's what I need to be able to see with my eyeballs, right? So I'm looking for where the slope of the graph in front of me is 0 or does not exist. Remember, a 0 slope means level, right? Like horizontal, right? And a DNE slope would be something where there's like a point or a cusp. So I look at this and I say, cool, well, there's definitely a, so the tricky part you're gonna run into is when the slope switches from 0 to 0, but we'll deal with that in a sec. So here I have a 0 slope and it switches to positive, right? So although this is a spot where the slope doesn't exist, I switch from 0 to positive, so that's not an issue. Here, again, my slope doesn't exist. So the places where G double prime does not exist are at x equals -2, but at this moment it switches from 0 to positive, which is not a sign change, right? At x equals -1, I switch from positive to 0, which is not a sign change, right? I need to switch from positive to negative or negative to positive. At x equals 0, I have another pointy thing, but again, sorry, it wasn't G double prime, it was F double prime. My F double prime switches at 0 from 0 to positive, again, not a sign change. Again, same situation at x is 1, right? I switch from a slope that's positive to a slope that's 0. Again, not a sign change. Here, I have a slope of 0 to negative. So at x equals 3, I switch from a slope of 0 to negative, which is not a sign change. But here, finally, we have our winner. At x equals 4, this is a horizontal tangent line, right? So at x equals 4, f double prime equals 0, right? And I switch from a negative slope to a positive slope to positive slope. So my only answer is that at x equals 4, f double prime changes from negative to positive. Or the other way to say that is f prime changes from decreasing to increasing, right? F prime is decreasing, F prime is increasing, right? So the only answer is at x equals 4.